Implementation of Artemis program technologies by 2026, a comprehensive overview. Introduction. The Artemis program initiated by NASA in 2017 aims to establish a sustainable human presence on the Moon by 2026, serving as a stepping stone for future missions to Mars. This ambitious program is structured into 4 main phases backed by an estimated investment of $30 billion and focuses on deploying 5 key systems including the Space Launch System SLS and the Orion spacecraft. Key components and goals. 1. Space Launch System SLS. The SLS is a super heavy-lift rocket designed to transport the Orion spacecraft and other payloads into lunar orbit. The SLS will evolve through various configurations. Block 1, initial configuration capable of lifting 95 metric tons to low Earth orbit LEO. Block 1B, enhanced version with an increased payload capacity. Block 2, future configuration expected to lift up to 130 metric tons. Facilitating more complex missions. 2. Orion spacecraft. The Orion spacecraft is designed for deep space missions featuring a crew module and a European service module that provides propulsion and life support. Orion will transport astronauts beyond LEO and is integral to the Artemis missions. 3. Lunar Gateway. The Lunar Gateway is a planned mini space station in lunar orbit that will support both crewed and uncrewed missions. It will serve as a hub for operations on and around the Moon, facilitating easier access to lunar resources and conducting scientific research. 4. Human Landing System HLS. The HLS is responsible for transporting astronauts from the Gateway or Orion to the Moon's surface. SpaceX's Starship has been selected for Artemis missions, complemented by additional landers developed by Blue Origin for future missions. 5. Additional supporting elements. The Artemis program also includes various supporting infrastructures such as the Commercial Lunar Payload Services (CLPS) for robotic lunar landers, the Artemis Base Camp for extended lunar habitation, and advanced spacesuits for astronauts. Timeline of events. 2017, the Artemis program is officially established with the goal of returning humans to the Moon. 2022, Artemis I, an uncrewed mission, is successfully launched on November 16, testing the SLS and Orion systems. 2026, Artemis II, the first crewed mission, is scheduled for April, involving a lunar flyby. 2027, Artemis III aims for the first American crewed lunar landing since Apollo 17, contingent on the successful deployment of the Starship HLS. 2028, Artemis IV will deliver the International Habitation Module IHAB to the Lunar Gateway. 2030 to 2035, subsequent missions Artemis V2X will expand lunar exploration and establish a lunar base, with annual missions expected post-Artemis VI. Program structure and phases. The Artemis program is organized into 4 main phases, each building upon the success of previous missions. Phase 1, initial testing and uncrewed missions. Focus, validates systems and technologies through uncrewed missions, e.g. Artemis I. Goals, test the SLS and Orion spacecraft's capability to operate in lunar orbit. Phase 2, crewed lunar flybys. Focus, conduct crewed missions, e.g. Artemis II, to perform lunar flybys and gather data. Goals, ensure crew safety and system functionality for deeper space missions. Phase 3, crewed lunar landings. Focus, establish a human presence on the Moon through missions like Artemis III. Goals, achieve the first American crewed lunar landing since Apollo and perform surface exploration. Phase 4, sustainable lunar presence. Focus, develop the Lunar Gateway and establish a lunar base, e.g. Artemis IV and subsequent missions. Goals, create a sustainable human presence on the Moon, paving the way for future Mars missions. Financial overview. The Artemis program is expected to require a significant investment estimated at around $30 billion. This funding will be allocated to various components including the development of the SLS Orion spacecraft Lunar Gateway and HLS as well as operational costs for the planned missions. Budgetary challenges have been noted with the NASA Inspector General citing concerns over the program's financial sustainability. Challenges and criticism. The Artemis program faces several challenges including budget constraints. The program's ambitious goals have led to concerns over funding adequacy and potential delays. Technological development. The complexity of the systems involved, particularly the SLS and HLS, has raised questions about timelines and readiness. Sustainability concerns. Critics have pointed out the need for a sustainable approach to lunar exploration, emphasizing the importance of international collaboration and resource utilization. Common points across sources. The Artemis program is a collaborative effort involving multiple international space agencies and private sector partners. A strong emphasis is placed on sustainability and establishing a long-term human presence on the Moon. Each mission builds upon the success of its predecessors with increasing complexity and capabilities. Conclusion. The Artemis program represents a significant leap forward in human space exploration, integrating advanced technologies and international partnerships to achieve its ambitious goals. With a structured approach divided into 4 distinct phases, the program is set to not only return humans to the Moon but also to lay the groundwork for future exploration of Mars and beyond. As the scheduled missions approach, ongoing developments and challenges will need to be managed to ensure the program's success and sustainability. The successful execution of the Artemis missions will mark a new era in space exploration, fostering international cooperation and advancing scientific knowledge while inspiring future generations. The Artemis program, initiated by NASA in 2017, is an ambitious project aimed at returning humans to the Moon by 2026 and laying the groundwork for future crewed missions to Mars. It encompasses a series of missions that will utilize new technologies and international partnerships with an estimated investment of $30 billion, leading to the deployment of key systems like the Space Launch System SLS and the Orion spacecraft. Key components and goals. 1. Space Launch System SLS, a heavy-lift rocket designed to launch the Orion spacecraft and other payloads to lunar orbit. It will evolve through different configurations: Block 1, Block 1B and Block 2, each enhancing payload capacity. 2. Orion spacecraft, intended for deep space missions. Orion will carry astronauts beyond low Earth orbit and features a crew module and a European service module for propulsion and life support. 3. Lunar Gateway, a mini-space station in lunar orbit that will support crewed and uncrewed missions and facilitate operations on the Moon. 4. Human Landing System HLS, a lunar lander responsible for transporting astronauts from the Gateway or Orion to the lunar surface. SpaceX's Starship has been selected for this role, with Blue Origin also developing a lander for future missions. Mission timeline. 2017. Artemis program officially established with the goal of sustainable lunar exploration. 2022. Artemis I, an uncrewed mission, successfully launched testing SLS and Orion systems. 2026. Artemis II, the first crewed mission, is set for April, involving a lunar flyby. 2027. Artemis III aims for the first American crewed lunar landing since Apollo 17. Contingent on Starship HLS deployment. 2028. Artemis IV will deliver the International Habitation Module IHAB to the Lunar Gateway. 2030 to 2035. Subsequent missions. Artemis V2X will expand lunar exploration and establish a lunar base, with annual missions expected after Artemis VI. Common points across sources. The Artemis program is a collaborative effort involving multiple international space agencies. Sustainability is a key theme, with a focus on establishing a long-term human presence on the Moon. Each mission builds upon the successes of previous ones, progressively increasing in complexity. Differences between sources. Some sources highlight budgetary challenges and potential delays, noting critiques of unrealistic timelines from the NASA Inspector General. Variations in projected costs for specific missions and gateway elements reflect different fiscal perspectives. Counterintuitive information. 1. Increased complexity over time, although the program is designed to build upon each mission's success. The increasing complexity and interdependencies between missions may lead to delays and challenges that could disrupt the program's timeline. 2. Significant cost projections. Initial estimates for the Artemis program's costs have ballooned significantly, with projections indicating that the total expenditure could exceed $93 billion by 2025, contrary to early assessments that suggested a more manageable budget. 3. International collaboration versus competition. The program involves a significant amount of international collaboration, yet it has sparked competition among U.S. companies like SpaceX and Blue Origin for contracts, which can lead to conflicting priorities and delays. 4. Technological reliability. While the Artemis program relies on advanced technologies like the SLS and Starship, the history of aerospace projects shows that new technologies often face unforeseen challenges that can result in delays, contradicting the assumption that new systems will perform as intended from the outset. In essence, the Artemis program represents a multifaceted approach to lunar exploration that intertwines ambitious goals with complex logistical and budgetary challenges, reflecting both the potential and the pitfalls of modern space endeavors. The Artemis program, which aims to return humans to the Moon and establish a sustainable presence there by 2026, has garnered significant attention. However, there are critical aspects of this ambitious initiative that are often overlooked. Below are some of these key elements along with their significance. Interdependence of key systems. One of the most crucial yet underappreciated aspects of the Artemis program is the intricate interdependence of its key systems: the Space Launch System (SLS), the Orion spacecraft, the Lunar Gateway, and the Human Landing System (HLS). Each component is not merely a standalone entity but part of an elaborate ecosystem designed to achieve the program's objectives. 1. Space Launch System (SLS). The SLS is the backbone of the Artemis program, designed for heavy lift capabilities to transport the Orion spacecraft and other payloads. The evolution of SLS through its various blocks, Block 1, Block 1B, and Block 2, is essential. The SLS Block 2, anticipated for use in missions beyond 2028, will have enhanced payload capacity, allowing for more complex and ambitious missions. The significance of this interconnectedness lies in the potential for mission delays if any of these components fails to meet its timeline or requirements. 2. Orion spacecraft. Orion's role extends beyond just ferrying astronauts. Its design is predicated on deep space missions, making it indispensable for lunar and Martian explorations. The European Service Module ESM will provide vital life support and propulsion. Yet its development is often overshadowed by the SLS. 3. Lunar Gateway. Serving as a mini space station in lunar orbit, the Gateway's function is often underestimated. It is intended to facilitate crewed and uncrewed missions and support operations on the Moon. The success of Artemis missions hinges on the Gateway's timely construction and functionality, which is currently scheduled to be delivered in phases. 4. Human Landing System (HLS). The selection of SpaceX's Starship as the primary HLS has sparked discussions, but the significance of having multiple HLS providers, including Blue Origin's Blue Moon, is often overlooked. This redundancy is vital for risk management, ensuring that if one system encounters issues, another can step in. Budgetary constraints and fiscal management. While the total investment for the Artemis program is projected at $30 billion, the reality is that costs can spiral due to unforeseen challenges. The NASA Inspector General has previously expressed concerns about budgetary constraints and the potential for delays. 1. Cost overruns. Past space missions have shown that budget overruns are a common issue. The Artemis program is no exception, with estimates suggesting that the overall cost could reach upwards of $93 billion. This significant financial commitment requires vigilant oversight to prevent misallocation of funds. 2. Impact on future projects. The substantial financial investment in Artemis may divert resources from other critical NASA projects. The implications of this can be dire for international partnerships and ongoing scientific research, particularly as space exploration evolves. International collaboration and partnerships. The Artemis program emphasizes collaboration with numerous international partners involved, including the European Space Agency ESA, Japan's JAXA, and the Canadian Space Agency CSA. 1. Artemis Accords. The establishment of the Artemis Accords aims to set a framework for responsible exploration of outer space. However, the complexities of international agreements can lead to delays and misunderstandings, which are often overlooked in discussions about the program's progress. 2. Shared resources. The reliance on international partners for components like the Gateway modules and the Orion service module underscores the significance of maintaining strong diplomatic ties and operational synergy. A breakdown in these relationships could jeopardize the entire mission architecture. Technological innovations and sustainability. Artemis is not just about returning to the moon, it also pivots towards sustainable exploration and technological advancements. 1. In situ resource utilization ISRU. The Artemis program incorporates plans for ISRU, focusing on utilizing lunar resources for fuel and life support. This aspect is often sidelined in favor of more immediate mission objectives, but is crucial for long-term human presence on the Moon and Mars. 2. Sustainable practices. The program aims to develop sustainable practices for future missions. This involves designing systems that can be reused and repurposed, which could significantly reduce costs and environmental impact over time. Criticism and skepticism. While the Artemis program has ambitious goals, it also faces skepticism from experts and critics who question its feasibility. 1. Unrealistic timelines. Numerous experts have labeled the proposed timelines as overly optimistic. Delays in the launch of the SLS and Orion spacecraft have already pushed back key missions, and the potential for future setbacks remains high. 2. Debates over mission architecture. Critics like Robert Zubrin advocate for alternative mission architectures, arguing that the current plan may not be the most efficient. The debate highlights the need for flexibility and adaptability in mission planning, which is often lost in the narrative of progress. Conclusion. The Artemis program represents a monumental step in human space exploration, but the complexity of its execution is often underestimated. The interdependence of its key components, the financial implications, the importance of international collaboration, the focus on sustainability, and the criticisms it faces are all vital elements that deserve attention. Recognizing these factors will not only enhance public understanding but also contribute to the program's successful implementation and future advancements in space exploration. The Artemis program represents a monumental effort by NASA to return humans to the Moon and establish a sustainable presence there by 2026. It is structured into 4 main phases, with a projected investment of $30 billion and the deployment of 5 key systems. Here are 4 valuable points for in-depth analysis and discussion. 1. Phased approach and milestones. The Artemis program is delineated into 4 distinct phases, each with specific milestones and objectives. The timeline includes Artemis I 2022. This uncrewed mission successfully tested the Space Launch System SLS and the Orion spacecraft. Artemis II 2026, scheduled as the first crewed mission. This will involve a lunar flyby testing the systems in a crewed environment. Artemis III 2027 aims for the first American crewed lunar landing since Apollo 17, contingent on the successful deployment of the Human Landing System HLS. Artemis IV 2028. This mission is expected to deliver the International Habitation Module IHAB to the Lunar Gateway, further facilitating human presence on the Moon. Each mission builds on the successes of its predecessors, increasing in complexity and scope, and setting the stage for subsequent missions aimed at establishing a sustainable lunar base and preparing for future Mars missions. 2. Key systems and technologies. The Artemis program will deploy 5 key systems that are critical to its success. Space Launch System (SLS), a heavy-lift rocket designed to transport the Orion spacecraft and payloads to lunar orbit. It will evolve through various blocks to enhance payload capacity. Orion spacecraft, capable of deep space missions. Orion will transport astronauts beyond low Earth orbit featuring advanced life support and propulsion systems. Lunar Gateway, a mini space station in lunar orbit designed to support crewed and uncrewed missions facilitating operations on the Moon. Human Landing System (HLS), a lunar lander primarily SpaceX's Starship. Selected to transport astronauts from lunar orbit to the Moon's surface. Commercial Lunar Payload Services (CLPS), a program to deliver scientific payloads to the Moon via commercial partnerships. These systems represent a convergence of advanced technologies and international collaboration, emphasizing the importance of both government and private sector partnerships in modern space exploration. 3. Budgetary considerations and challenges. The Artemis program's estimated cost of $30 billion raises important questions about budget management and fiscal sustainability. Key points of discussion include: funding allocation. The budget must cover the development and operational costs of multiple systems including SLS, Orion, Lunar Gateway, and HLS. Contingency planning. The potential for cost overruns and delays as noted by the NASA Inspector General suggests that budget flexibility and contingency measures are vital for success. Political support. The program's continuation and funding are subject to political will, necessitating broad bipartisan support to ensure long-term financial backing. The management of these financial aspects will be crucial to maintaining the program's timeline and objectives. 4. International collaboration and partnerships. The Artemis program is not solely a U.S. endeavor. It involves collaboration with multiple international space agencies including the European Space Agency (ESA), Japan's JAXA, and others. This aspect is significant for several reasons. Shared expertise and resources. Collaborative efforts can leverage the strengths of various agencies and private companies, enhancing the program's capabilities and reducing costs. Artemis Accords. These accords establish a framework for cooperation among nations participating in lunar exploration, emphasizing transparency, sustainability, and the peaceful use of outer space. Long-term goals. This international collaboration lays the groundwork for future missions to Mars, highlighting a commitment to shared exploration goals and the potential for sustainable human presence beyond Earth. In conclusion, the Artemis program represents a comprehensive approach to lunar exploration, integrating advanced technologies, strategic planning, budgetary considerations, and international collaboration. Each of these points offers rich avenues for further analysis and discussion as NASA works toward its ambitious goals. 1. Apollo Program 1961–1972. The Apollo program was NASA's flagship program for human space exploration, culminating in the first crewed moon landing in 1969 with Apollo 11. Over the course of 6 missions, Apollo successfully landed astronauts on the lunar surface, conducted scientific experiments, and returned samples to Earth. The program's primary objectives were to demonstrate human spaceflight capabilities and to explore the Moon, paving the way for subsequent missions and establishing a legacy of human exploration beyond Earth. 2. Mercury and Gemini programs 1958–1966. These early programs laid the groundwork for human space exploration and were critical in developing the technologies and techniques needed for space travel. The Mercury program aimed to send humans into space and safely return them, achieving its goal with the successful flights of astronauts like Alan Shepard and John Glenn. Following Mercury, the Gemini program focused on longer duration flights and space rendezvous, which proved essential for the later Apollo missions. Together, these programs built the foundation for sustained human presence in space. 3. International Space Station 1998–present. The ISS represents a significant multinational collaborative effort in human space exploration and research. Launched in 1998, it has involved multiple space agencies including NASA, Roscosmos, ESA, JAXA, and CSA. and serves as a microgravity and space environment research laboratory in which scientific research is conducted in astrobiology, astronomy, meteorology, and other fields. The ISS has been continuously inhabited since November 2000, demonstrating the viability of long-term human presence in space and serving as a platform for future exploration beyond low Earth orbit, including Mars missions. The Artemis program, initiated by NASA in 2017, aims to establish a sustainable human presence on the Moon by 2026, paving the way for future missions to Mars. The program consists of 4 main phases with an anticipated investment of $30 billion and the development of 5 key systems, including the Space Launch System SLS and the Orion spacecraft. This document provides an overview and future outlook for the Artemis program. Future outlook and predictions. 1. Phase development timeline. Artemis II 2026. The first crewed mission is set for April 2026. Involving a lunar flyby. This mission will test the Orion spacecraft's capabilities with a crew on board, marking a significant step towards sustainable lunar exploration. Artemis III 2027, expected to be the first American crewed lunar landing since Apollo 17. The mission is contingent on the successful deployment of SpaceX's Starship human landing system HLS and aims to land astronauts near the lunar South Pole, where water ice and other resources are present. Artemis IV 2028. This mission will deliver the International Habitation Module IHAB to the Lunar Gateway, expanding the capabilities of the lunar outpost. Artemis V 2030 and beyond. Beginning in 2030, annual missions are expected to increase the complexity of lunar exploration, including the establishment of a lunar base and expanded surface operations. 2. Technological innovations. Space Launch System SLS. The SLS will evolve from Block 1 to Block 2, with increasing payload capacities that will be critical for future Mars missions. By 2030, the Block 2 version will be capable of carrying 130 metric tons to low Earth orbit (LEO), enabling larger payloads and more ambitious missions. Orion spacecraft. The Orion spacecraft is designed for deep space missions featuring advanced life support systems and autonomous capabilities. Future iterations may include enhancements based on mission feedback to improve performance and safety. Lunar Gateway. The Gateway will serve as a staging point for lunar missions, facilitating crewed and uncrewed missions. Its modular design allows for international collaboration and the integration of new technologies as they develop. 3. International collaboration. The Artemis program fosters partnerships with international space agencies such as the European Space Agency (ESA), Japan's JAXA, and Canada's CSA. These collaborations are expected to enhance scientific research and technological advancements, leading to a more robust lunar exploration framework. 4. Commercial partnerships. The program relies heavily on commercial partnerships, particularly for lunar landers and supply missions. Companies like SpaceX and Blue Origin are critical to the success of the Artemis program, providing transportation and logistical support that will drive innovation and reduce costs. 5. Sustainability and resource utilization. One of the central goals of the Artemis program is to establish a sustainable presence on the Moon. This includes the development of in-situ resource utilization (ISRU) technologies to extract water and materials from the lunar surface, which can support long-duration missions and reduce reliance on Earth-based supplies. The establishment of a lunar base will allow for continuous human presence, facilitating research on the Moon's geology, potential resources, and the effects of long-term space habitation on human health. 6. Preparation for Mars missions. The Artemis program serves as a stepping stone for future crewed missions to Mars, with lessons learned from lunar exploration informing the development of technologies and strategies needed for interplanetary travel. By the mid-2030s, NASA aims to send humans to Mars, leveraging the experience gained through the Artemis missions to ensure safe and effective exploration of the Martian environment. 7. Potential challenges. Budgetary constraints and political changes may pose challenges to the Artemis program's timelines and funding. The NASA Inspector General has raised concerns about the program's ambitious schedule and potential delays. Continuous advocacy and public interest in space exploration will be crucial to securing support for future missions. Conclusion: the Artemis program is set to transform our understanding of the Moon and lay the groundwork for human exploration of Mars. With a focus on sustainability, technological innovation, and international collaboration, the program aims to create a new era of space exploration that not only advances scientific knowledge but also fosters the development of technologies that can benefit life on Earth. As the program progresses, it is essential to remain adaptable to challenges and capitalize on opportunities that arise in the rapidly evolving landscape of space exploration.